Hi, welcome back. Sorry for last week. I have been having a not good fever. And then what happened? Yes, am I feeling now? I think I'm okay. I'm still a bit foggy, okay? So if today I accidentally leak out some midterm or final question, please do not treat it through. Right? Before we go on, there's something I owe you. Last time we talked about recursion, right? Let's do recursion. What's recursion? Recursion is like this. It's you, all your handsome you guys, and recursion is this. Ooh, this is recursion. You can make you guys DC by rotating. Interestingly, the odd number ones are state the correct orientation. You see. Try again. Huh? You see, even no matter how I turn it, the odd number one are correct. It didn't rotate. Some black magic. See? Yeah. Okay, let me make you DC by this. Ooh. Okay. That's enough for recursions. Let's start our today's lecture. Before we go on, assignment 2. Do you guys forgot to submit? Because the 90 people attempted, but they submitted, right? Oh, yeah, they submitted. Sorry. My fault. What about these 14 people? Probably these 14 people have some dropout or something, right? I need to figure out what happened to that 14 people. The assignment 1 about around that. So these 14 people, if really you haven't submit whatever, please check it, okay? Otherwise, probably we have something wrong with. Okay, let's start. Assignment 2 already almost finished marking. We have about 100 people, and it's good submission rate. And this assignment 2, assignment 3. So please start. Assignment 1 and 2 are warm-ups. Assignment 3 going on is something we're going to get real. So you expect a big time of how come the private case doesn't go through. And I just give you a hint for the binomial coefficient, think integer. Okay, that's my last hint to you guys. Okay, think integers. Why you think integers? I think I already talked about that in lecture 2. So think integers. Let's start today. Yeah, today we are going to talk about something complicated. And I will say this is the starting of real. If you, after today, you're going to be able to program a lot of things, okay? A lot more. Today, we are going to open a door that let you to manage a lot of volume of data, okay? Not just computing one number, prime numbers, or what. So today, we're going to talk about a big topic. And to be honest, before we start, this is not easy, okay? This one, even nowadays, after I have almost like 10 years of Python, I still learn new thing about list today. So this one, I really need you guys to have the mentality of practicing. There's a lot of weird things, scary things happening. Later I will show you something what is scary, okay? Let's talk about sequences. By the way, the term collections and sequences are not anyhow terms. They are real terminology in Python. That means you talk about sequences, people will know that you refer to the following few data type. Okay, I hope you guys remember your chemistry, okay? What does chemistry tell you? Things are made of atoms. There was, of course, some people will say, oh, even more smaller particle. Some people will say electrons, protons, some people will say quark, whatever. But let's talk about, we start with the simple elements like atoms. But you know, in this world, we seldom use pure fewer elements, right? You combine, for example, hydrogen and oxygen combine in the water. You have methane that are few hydrogen and carbon will combine with methane. And most importantly, I think one thing we all use in a massive manner is polymers. What is polymers? Polymers is when you have some atoms that repeat itself and link together, like your plastic. Or actually, in some sense, your metal has the same property. The metal atom, they arrange in the same manner and they repeat themselves as a pattern. Okay? So if you have a large structure like that, you have great power. You become strong structure. So in Python, we have the same thing. We have been introducing the primitive data types. They are different. Today, you know that why they call primitive data type. Because they're going easy on you. It's really easier. Later today, you will find that something, oh man, the world is that complicated. Okay. These are called primitive data types, like integer, Boolean, float, and even string. And Python, you can actually use simple data type to say a few of them to assemble together to be a more complex structure. For example, in mathematics, you know there's something called rational number. Rational number is not simply floating points. Rational numbers means in mathematics is one integer divided by another one. For example, the number pi or the square root of 2 are not rational numbers. So in math, they have this type of divisions, okay? For example, I can do a few of your data type. I can use a string and use some number to record your student record. Okay. Your student name is a string, your student number is another string, and then your grades is some kind of numerical method. I can put them together in one entity. And of course, if you have that, I will have a collection of the same data, which is, we call it sequences today. So this will be something like polymer. I'm going to repeat a lot of same type data and put them together. Okay, and of course, we talk about strings and we talk about sets and dictionary. So we try to go through all this today. Think about this. Today, I'm going to ask you to write a very simple program. You're going to write a program to record all the scores of our class. If you just have one student in your class, it's very simple. I can create a variable called Peter score. Okay? If you know all the names, I can create a variable called Peter score, one called Mary score, one's called John score, and so on. But what if I'm going to do this class, CS1010E, have 700 students? Am I going to create 700 variables to compute whatsoever data out of you? And even you created that, how am I going to go through all the data and so on? It's actually not workable. I cannot create a variable with a unique name for every entry of you guys if I write a program. And you know this is called hard coding. What does that mean? That means every student will have its own variable name that is not going to flexible for any other classes and so on. So this method is not going to work. How about another example? For example, I want to store 100 nice restaurant location. How do I store it? If you remember your geometry or whatever, you can actually store it with the latitude and longitude, right? That's how Google store the position of whatever we have. Well, of course, it's not 150 lah. With our longitude and latitude, we have more complicated number. But basically, it's two numbers. And then you have a lot of restaurants. How do you store all this data? Are you going to create some variables for each of this entity? The answer is no. So we are going to introduce something in other language called array or list, we call it sequence. A collection of something. We talk about collection. For example, if you talk about what is a movie, the movie file on your laptop. For example, you use an iPhone and video, take some funny video. What does it call? What is that? A video is actually a sequence of images. You can stop at every different time slot to see, oh, there's one image there. And I want you to notice one more property of sequence instead of, or rather a rubbish collection of set is, or heap is, sequence on top of have a lot of data. Every data have its sequence. I'm saying rubbish. Every data have its order. When you watch a movie, you know which frame is after each frame and after each frame. You won't suddenly after frame 10, you watch frame 1. You don't randomly play the frame. The movie only makes sense when you play the movie from frame 1, frame 2, frame 3, and so on, right? Yep. Yes. So we talk about some ordered sequence in Python, which is strings, list, and tuple. And some unordered sequence is set and dictionary, okay? We usually treat the set and dictionary as unordered one. And we can finish it today, although I write it here, okay? Because usually in other semester, we'll use this lecture to brief exemplify, but we decided we'll do it next week. So this week, we have more time. So you can talk about more about all these list, strings, and tuples. Okay, recap, nothing new first. Remember what is strings? Strings is, for example, my name is Alan, or call is whatever, IT 501, IT CS 1010, whatsoever, right? And remember what you can do with string, right? You can try to use an index to specify which character is talking about. For example, it's 2. 2 is the third character, so it's the character 1. Nothing new yet, okay? But do you notice a string is actually a sequence of character? They are in a sequence. They have, what do you mean by sequence? A sequence means each element has an order. You first have the first one, which is index 0. The second one is index 1. The third one is index 2 and so on. They have an order. Okay, it's not like you sitting here, you have no order, right? I don't know who is coming first, whatever. But when you go to a bus stop, you queue, there may be an order, right? So you have some order with the sequence. And you know that, for example, if you have a string of A, B, C, D, E, F, whatever you do, slicing, addressing certain entity is all because each of the character has its index. This property is called a sequence because they have the numbers, they form an order, and they have a sequence. So strings are sequences of characters. And if you remember that, if you have a sequence, you can do all this start, stop, step. This is all the operations you should be familiar by now. After your tutorials, the Burger Prize, and also other assignments. Like, for example, how to access one of the, for example, how, if like S1 is minions like bananas, this is accessing one character. This is doing slicing, which means I select one of the substring of my whole string. I can talk about, I can ask that what is the length? How many characters is there in the string? I can find the max and min. I can ask if something is in my string. And finally, I can do concatenation. That means I have 2 strings. I add them together, or I can do multiplication. Okay? These are all you should know by now. If you don't know about this, please remember to go through our first 4 lectures again. But why am I so 長氣 and repeat this? Because if strings are sequence of characters, what are lists? Lists are, so if strings are sequence of characters, lists are sequence of anything. Imagine that your string, every character, instead of putting one character, you can put anything. You can put a number. You can put a Boolean. You can put whatever, okay? So let's see what does it look like. This one. This is how I define a list of even numbers. So I call the list called even numbers. And even numbers is equal to square blanket inside the sum numbers. And you separate each number by a comma. Okay? Simple, right? And how many elements are there in this list? 1, 2, 3, 4, 5, 6, right? So it's 6 number there. I can create a sequence of anything. That means I can create a sequence of strings. Okay? So there's three names, Peter, Paul, and Mary. Anyone who knows who is Peter, Paul, and Mary? Anyone knows there's a band called Peter, Paul, and Mary? Okay lah, probably even your mom didn't know. It's quite old already. This is like a very old. At our time, we have something called folk songs. Anyone know what is folk songs? Folk song is those people like sitting with a guitar, with a cowboy hat and sing like that. So Peter, Paul, Mary has a lot of nice songs like Puff the Magic Dragon. Anyone knows about that? Puff the Magic Dragon sleeps by the sea. Oh, how many? Oh, never mind. I'm not going to torture you, okay? But nice song. At our time, it's like folk song, okay? Interestingly, the list can contain anything. And there's one thing to those C and Java people. Python list is free. That means even inside the same list, you can even contain different types. Do you see that? This is my answer to universe. The list is called. And what's that? Something, nothing. Some say that the answer to universe is some deity, some gods, right? Some people think it's 42. Why is it 42? Yeah? Is it? Yeah. Some people think it's true, some of it is none, okay? So you can see that different data types. Some are strings, some are integers, some are Boolean value. It doesn't matter. In Python, you can store totally different heterogeneous type of data in a list, okay? Yeah, so of course, if it's a list, you can do whatever just now. The index, the slicing, the max, mean, whatsoever in your list. Okay? So you can ask what is the length of the list and so on. You can do slicing, whatever. So this is why we call the answer to universe. So you can go and Google. If you ask Google what is the answer to life and universe and everything, tell you 42. Okay? So let's later bit explain why I say 42. Yeah. Okay, so you can do what is the length of your list. You can ask what is the type of the list. If you ask what is the type of the whole list, it's a list. But you can get every entry in the list. For example, 0. This one is a string. This one is an integer, number 2, right? And this one is the non-type. So you can actually get each of the entry and store different types even in a list. This one is not that normal for other programming languages. If you use C, the whole array or the list has to be the same type. Like all have to be integers, all have to be float and so on. But for Python, you have very free form of doing any type you want. Remember this? So we can do all this for the list. Even this. If you use it on a string, it's concatenating to one, right? Two strings. But you can do this concatenation on 2 lists. So what is the even number plus my good friends plus my answer to universe? You just link them together like a train up. Okay? So it's a big list of anything you want. Then what about this multiplication? This multiplication is like a string, like you multiply 3 times. For example, if it's Peter, Paul, and Mary, multiply 2 times, it's Peter, Paul, and Mary, Peter, Paul, and Mary. Okay, so this is the normal operation for basic list. And usually we will do this operation called append and remove. What do we do? Because this one, right, for example, Peter, Paul, and Mary, you have 3 entries. The even number, you have 6 numbers. I can change the length of the list by append and remove. For example, I have Peter, Paul, and Mary. I do Peter, my good friends dot append. You can see after the append, it does not show you anything, but this append operation changed the list of my good friends internally. And also, I want you to recognize this syntax. My good friend dot append, something, something, dot something. This is very important. This syntax is going to follow you the whole course. Okay? It means the object, the object of this, the main character is my good friends. And then for this my good friends, I will do something to it. It's called append. Append means I will add 1 more item at the end of the list. And this is important. Remember this, okay? Whenever you do append, you add 1 and exactly 1 item to the list. Later I will tell you why is it important. Of course, you can remove, okay? I can remove Paul from the list. So you can see the list become Peter, Mary, and John because Paul is being removed. So if you use the remove function and there's no Paul there, for example, now if I want to say, my good friends dot remove Benny, then you will crash the program. The program will totally red lines and tell you, oh, crash, there's no such thing as barrier, okay? So be careful about that. When you try to remove, use the function remove in a list, something in the list, that if that item is not in the list, you will crash the program, okay? So be careful about that. How about this? You remove something, right? What if I have multiple copies of that something in the list? For example, you can see that in my list, I want to remove the number 2. But now I have 2 2s there. 1, 2, 3, 4. 1, 2, 3, 4. I have 2 2s there. How many 2s will I remove? 1, 2. Okay? This is confusing. The answer is what? How many 2 I will remove? Only 1. And the leftmost ones, okay? And congratulations, you will get it in midterm because you remember this. You get it correct, right? So I have the whole list. For example, I can make a list like that. I can make a list. List 1 is equal to 1, 1, 1, 1, 1, 1, 1. I have a list of 6 ones, but I can say list 1 dot remove 1. And if I talk about this one, you see I only remove 1 of the items and the leftmost ones. Okay? If the leftmost one is important because you may forget, is it the rightmost one, the middle one, or random one, or what? Python will remove the leftmost ones. So if you don't believe me, you can do a list like that. Do a list 1 is equal to 1, 1, 2, 1, 3, 1, 4, 1, 5. Okay. So if I want to remove 1, which one will we remove? The leftmost one, which means my list will start with 2. Okay, I will not remove the one between 4 and 5 and so on. So remove the leftmost one, the first occurrence of the number. Okay. So the first appearance will be removed. And of course, if 2 is not inside the list, it will cause an error. C. I said I can put anything in a list. Can I put a list into a list? I always say anything. So I can put a list into a list. But then the question is, if I say my good friends thought append the even number, which one is the correct final outcome? The upper one or the lower one? Who will say the upper one? Who will say the lower one? Okay, did I just said after append, you will only increase the number of items by 1 only, right? How many items on the upper answer? You say so many, but then for the list on the top level, it only counts as 4 items. 1 Peter, 1 Mary, 1 John, and 1 list or whatsoever. I don't care. I don't care. It's even number or number. It's 1 list. So that's why it's only increased by 1 item. And that's why the correct answer is this one. Okay. What is the second one? If I want to do the second one, what do I do? Huh? Extend. Or something I taught just now. Plus, right? I can just plus. So if you have my good friends plus even number, it'll be the second one. Okay? So I do a visual demonstration. What is that? Append to a list is different from concatenation from a list. For some concatenation, the list is like you in MRT, you have 2 passengers sitting like that, and you have 2 passengers sitting like that, and they sit together like that. They're all parallel, okay, on the same seat. But sometimes it's like that. In a seat, in a position, you can put a lot of things there. Okay, you can put a mother carrying a baby, the baby carrying his brothers, and so on. So you can stuff a lot of things in one entry. So that's what append do. I don't care how complicated that is, but I only put the extra new item in 1 slot only. Okay, so that is the difference between append and concatenation. And if it's a list of anything, I can put a list of lists. For example, I have list 1 is 1, 2, 3. List 2 is ABC. And list 3 is list 1 and list 2. And so on. And you already fell in the trap of vicious cycle, whatever. This is horrible. This is not something easy to understand. I try to explain it in the few slides later, okay? You can have list 4. List 4 is equal to true, and list 3 and list 1 and so on. On this slide, I already need to explain like half an hour what's going on, okay? But before that, let's talk about why list is so complicated. For a list, first, I want you to learn list you need to write in a block diagram like that. This is to help you to visualize what is the structure. What does that mean? If I say list is equal to 1, 2, 3, I want you to think about that. List 1 is the name. The name is pointing to a container, which is a square blanket, which is called a list. And this list is containing 1, 2, 3. So for the ABC, it's the same, right? No problem, right? Okay. But if you do anything like list assignment, okay? What is list assignment? You remember what is assignment, right? X equal to 1, then it's assignment. Assign 1 to X. X equal to Y, it means assigning Y to X. But list assignment is very complicated. I want you to, so now if you are getting sleepy, hit your head, okay? What will be the output of this? List 2, 0 means I use list 2, I change it to 999, the 0 position. I can do that for a list. For any entry, you can anyhow change its numbers. I'll let you to think about that first, okay? Would it be 99923, 9923, or is it 123, 99923? Okay? Let's explain what is the mechanism for this one first. Have you decided? You remember yourself, okay? Remember this yourself first. The answer is this one. Why? Water. Okay, this is the water. Actually, you know, if you search for online, there's something called Python water properties, okay? You can see there's a lot of very insane property of Python. But let's explain why slowly. And this phenomenon is going to trouble you for the entire semester. But if you can master it, congratulations, you are already an intermediate Python programmer, okay? Let's see what is going on. Go back to our primitive data type, okay? Primitive means integer, float, and Boolean. First, A equal to 1. A is Alex, okay? Alex have 1. Is it okay? What do you mean by B equal to A? B equal to A means this guy, Bob, B, right? He also want what Alice has. Okay? However, this is something you may miss. If I do this, actually, it's like that. Alice have a ball of 1. Sorry, I skipped 1. Bob will also have a ball of 1. Both of them have the ball of 1. But then now, if I change Alice, will I change Bob? They're separate, right? Bob already have a, if I have emphasized it many, many times, Bob has a duplication of the 1. That means you clone the 1 for Bob. And Alice, when you assign 2 to Alice, Alice will have 2 and it will not affect Bob. A is 1, B is 2. Won't change A. Sorry, you change A, you won't change B, okay? So that's why the final answer for this, if I ask what does Bob has? Bob has 1 now because he has the 1 that's separate. What happened is the primitive data type. However, for list, remember the list has a box. Okay? The box. The box is very important. Alex, A is equal to a list of 1 now. It's not 1 now. It's different from 1 now. For list, A is equal to a list of 1. So that means Alex have a box that inside containing 1. If you have a list of 1, 2, 3, that means Alex have a box of containing 1, 2, 3, okay? So the key point is Alice does have a box. What do you mean by B equal to A? B equal to A means Alex and Bob only have 1 box of things. That is different from the primitive data type. Do you understand? I won't duplicate the box of 1 for both of them. Both of them are referring to the same box of 1. It's called aliasing. They're sharing the box of 1. And when I say, Alice, get your box, and the first entry changed to 2, what's happening? You change this one to 2, right? What happened to Bob's box? Also got changed. Okay? Bob has the same box. It's not another box. So if you simply assign a list to another, the key point is it won't duplicate the whole list to others unless you use copy, okay? Let's talk about copy later. But that means if you say A equal to B or list 1 equal to list 2, this will not duplicate the list into a cloning of 2 copies. And that's why in this example, you change Alice. But when you print Bob, what does Bob has? Bob has a box of 2. That is what is happening. Okay? That is the very strange things about lists. I want you to remember this. If you don't remember or don't understand, don't worry. It's difficult, okay? But this one is a mystery and more mystery coming. So if you rerun the list, I want you to use the box program, the box representation. A has a list. The list has a 1. What do you mean by B equal to A? B equal to A like this. B is actually referred to the same list of Alice when you're doing list equal to another list. And that's why when you change A into 2, like that, you see the red word? I change Alice list into 2. Sorry, Bob got changed. So when I print the last line, what is in Bob's list? Become 2 lah. Okay? So that's what happened to this example just now. Okay, sorry, I didn't put another slide of that. So can you understand this now? List 1 is equal to 1, 2, 3. And when list 2 equal to list 1, I did not duplicate 1, 2, 3 into 2. So list 1 and list 2 are sharing the same list 1, 2, 3. So when I change list 2, the first entry to 999, list 1's list also changed lah, because they are only one list. Okay, so that is the answer why finally it become like this. Okay, and this one also happened the same thing like if you have a list of a list. This is also the same idea, because list 1 is still pointing to the list of 1, 2, 3. And list 2 is still pointing to the list of ABC. You have a list 3. That means any time you change list 1, or you change list 2, or you change inside list 3, everybody change. You want me to demonstrate? Let's try. Let's say list 1 is equal to 1, 2, 3, right? List 2 is equal to A, B, C. Just now I have list 3 is equal to list 1 and list 2. I even have list 4 is equal to true list 3, list 1. Okay. First of all, what's list 4? Let's print. Okay. List 1 is like that. List 2 is like that. List 3 is like that. List 4 is like that. Visually, okay. Visually only. Okay. Now, what should I do? Let me do list 1. The second element is equal to 999. Okay, what is list 1? Change, right? Very normal. What is list 2? Will list 2 change? No. Will list 3 change? It got changed. Okay. Will list 4 change? Wow, list 4 change until this change. You see? Because they are all referring to the same copy. This is very dangerous and very, very mysterious. Okay. This is all the problem about list. And I think I will give you enough at this moment. Before we go on, I give you another. Okay, let's start. This one is like that, right? This one is equal to 1, 2, 3, right? Oops. What's the list 1 dot append 4? What's that? This one is like that, right? No problem, right? I will have to say it more. What is this one dot append? This one. I'm not going to explain it. I will leave it as a nightmare for you. It works. What will be this one? That is the fun time you will do crazy thing without burning your computer. What is that? So list one, the first entry is this one, right? List one, the third entry is this one, right? What's list one, the fourth entry? Is it just dot dot dot? You know what is scary? More scary than Dylan last time? What is list 1, 4, 4? What have I done? Okay. Go to tutorial. Let's see. Trouble your tutor for that. Okay. I'll explain next time. But enough mystery. There's a lot of this kind of thing. But if you ever get the box right, actually it's quite simple. What if I say now list 3 is equal what if I say list 3 is equal to list 1, list 2, list 3? Then actually it means that there's one more entry from here. So it's one more item, right? And this item pointing to yourself again. Okay. And I let you to figure out, draw some figures. And one more interesting property of lists and iterables. What was an iterable we talked about before? Range is an iterable. That means when I do for I in a range, I will slowly go one by one, right? Let's go this. What are iterables? Not edible, with iterables. What are iterables? For example, let me start a new one. This is very scary, this one. No. Okay, never mind. What is iterables? If list 1 is equal to 1, 2, 3, 4, A, B, C, right? I can say for X in list 1, print X. I can iterate through that. That means each time my for loop, I can actually iterate through any item in the list. What else was iterable? We learned that for I in range 0 to 10, right? I can print I, right? There's also iterables. Iterables means I will let you to iterate through me, and each time I give you a value. Hey, wait a minute. The string is also iterable. How do I iterate through it? For C in CS1010E is cool and easy. Ha ha ha. And I print C. What would it be? Each time, what is each item? Each item is a character. Do you see that? So each line, I'm actually iterating through a character. To be more precise, I can say each time I iterate this, right? I can do this. Hey, I'm sorry. You see that? Each time I iterate CS1010E. So each time I iterate through that. Okay, so if I have a list for I total is equal to 0 for I in, actually I can do that. For example, in my string is equal to CS1010E. And I have answer is equal to an empty string. Sorry. answer is equal to empty string. I say for every character in S, answer is equal to C plus answer. What is that? I reverse the string. Why? How can I reverse the string? Let me try again. For example, if my string is equal to A, B, C, D, E, F, G, H, I. And then I do this again. Answer is equal to that. And answer. What's my answer now? Reverse. Why? I iterate through each character, and each time I put the character on the left. The later the character come, I put more left and more left or more left. And that's why I iterate through it and become reverse. Okay. So play around, have fun with the iterables. For example, a string is iterables, so you can actually do each character one by one. So for your burger price, probably you can do it already. And you can put for I in range. Range is also an iterable. That's what you have been using for loop. And then a list is also an iterable. Okay? And the good thing about the list is you don't have to care about what is actually in the list. Each time you just iterate through one item in the list. And I can iterate through the answer to universe, the answer to even number, the answer whatever I want. So anything you can look over is called iterables. Yeah. For example, I can answer for I in anything in the answer universe. Of course, I don't only print that. I can do some calculation. For example, I have all this even number. I just want to say, I want to have the sum of them. So I iterate through that, and I just add it to the answer. Okay, so that is adding up and do whatever you want. For example, if there's one day you have the list of all your classmates, let's say midterm marks. I can iterate through the whole class, add them together, and divide it by the length of the list, then become your average, right? Or I can calculate whatever data I want. So you can try to use this for all your computation. Now I try to write a function how to find the max items in my list. How do I do? I want to find the max number of this list, right? So first of all, I will do max so far. I assume the first person is the max first. And then I iterate through the list. What do I do? For each item in the list, if the new coming item is bigger than my original item, what do? I remember that, and so on. And finally, after I iterate through the whole list, the final remaining answer in the maximum so far will be the largest item. Okay? For example, it's like if today I want to find who has the most money in your wallet now. What do? I assume that he has the most money. Okay? He has $30. And then I check, what do I have? You have $20. Go away. How many do I have? $40. Yeah, 40. So what do I do now? I will replace the 40, the 30 by the 40. And then I ask you how much money you have? 100. Yes, I remember you. Then I will replace the 40 with 100. How much you have? Yeah. No money. Okay, go away. But I still will remember the 100. So after looping through, I go through the whole hall until the last person at the back. I will remember a certain number, and that certain number will be the most richest guy in this hall, right? And that is how the algorithm goes. Okay? Are you sure? What will go wrong? That is what your private test case usually are. What will go wrong? First hint is, will this find maximum usable if your list have only one item? Yes or no? What happens if this only have one item? you get the first item, and then you look through the list. The list is your first item, and it's the same as your cell. You still keep the first item. You finish. So the first item is the maximum. It's okay. What if your list have no item? You can have an empty list. I can put 2 squares, nothing there. You can have that. Will this program go right or wrong? Where will it burst? Which line will it crash? Yes, the first line. Why? The first line, I try to access the index 0. And there's no such thing as index 0 because there's no one there. So the first line will crash. Okay? And then the philosophical question is, if I have nothing in my list, who will be my max? I just want to say another level of program. Programming language sometimes for other languages have this thing called exceptions, and we call it undefined behavior. Okay, we'll talk about that in our error message. How do you check errors and how do we do exception later? Okay, so yeah. For example, this another function I try to demonstrate. If I have a list, I want to output another list which I filter out all the even numbers. So what do? I first create an empty list. I call it output. And then for every item in the list, if I modulo 2 equal to 0, what does that mean? If I divided by 2, the remainder is 0, that means I is divisible by 2 lah. Then if that's, I append it to the output of the list. Then this output will get more and more things, right? But it will only get a new item to append only if the item is even number. So afterwards, the output then is the filtering the even number out. Okay. You can convert a list to other type, right? But usually is you cannot convert a list to an integer because a list is a list. But you can convert the list from integer to a list. But the very precaution is if you have a string of 1, 2, 3, it will convert into a list of character 1, character 2, and character 3. Okay, that is very abnormal. But if you can go for the hidden meaning, because a string of 1, 2, 3 is actually a sequence of 1, 2, 3. So a sequence of 1, 2, 3 convert to a list of 1, 2, 3, then it's normal. Okay, not a list of single 1, 2, 3. It's a list of character 1, character 2, and character 3. But the horrendous thing is the reverse is not true. When you convert a list of 1 and 2 and 3, you will become a string like that. Okay, that is very abnormal. That means these two operations are not reversible. I convert this to a string to a list and a list to a string, then it will become something else. Okay, so don't think that you can be like back and forth, so what if I convert this into a list again? So if where's my item? So S is equal to 1, 2, 3, right? S list is equal to list of S. So S1 is SL. Is this one right? I convert it back to a string. SLS is equal to string of SL. SLS is equal to a string of this mess. What if I convert it into a list again? It will become, wow, each character become a list and so on. Okay, so the list and string conversion are not reversible for each other. Be careful. Okay. Aha, this one is one of the coolest things about Python. List comprehension. How do I build a list? If let's say I want a list, I need to use it for some data, okay? I want to plot a graph or whatever. I need a list that contains the number 1 to 100. What should I do? Well, for our normal, if you can catch up already with all the things we did in this past half an hour, we can actually do this, right? I can create an empty list. And then I loop through by a for loop such that for all the numbers, I append to the list. Okay? So I create a list of from 1 to 100. But Python has a more convenient and cool way to do that. Python can do this. List B is equal to the list of I for I in range whatever. Okay? This, I know that this is a very weird syntax, but if you can grab this power, you will shorten your code a lot. And what is this syntax? I'm sorry to say that this go back to your high school math, because this syntax is, anyone remember this kind of notation? How do you read the notation, the math notation? B is equal to, if you read it correctly, the last line, if you read it correctly as a mathematician, B is equal to the set of I for I is in the range of 1 to 101. What did I just read? I read the code. The notation reading is actually the code. Okay? So if you are familiar with the math notation you have been learning in your high school, writing the list comprehension is very simple. But of course, you can remember that. To go through that, this one is what you really store in the list. And then this one is how you iterate through the one. Why do I want to say what you really store in the list? Because you can change it to I plus 1. If you change it to I plus 1, your list will be from 2 to 101 and so on. So you can actually change the I to store in the list instead. How do I produce a list of the first 10 square number? Then I can do this. Similar, right? The D list is equal to I times I for I in range 1 to 10. The only difference is the first thing. I hope you can now know what do I mean by this one is the one you actually want to store in the list. You can actually I times I times I, then you have a list of cubic numbers. You can have I times 10, then you have all the tens, 10, 20, 30, 40, whatever. So you can put whatever numbers you want into the list to make it the list you want to. That's how you construct a list with only one single line. And this technique is called list comprehension. How do I produce a list of odd numbers? Go back to the last one. How do I produce a list of odd numbers? You can do through start, stop, step. Because remember the range, I start from 1. My range start with 1, go all the way to 100, and a step 2. Right? Step 2, because 1 step 2 is 3, 3 step 2 is 5, and so on. Then I don't need to write anything complicated. In order to generate a list of odd number, I can just do that. Okay, let me ask you a dumb question. How do I generate a list of even number? Well, it's a dumb question, and I'm going to introduce you a dumb solution. Okay? I can simply start with the previous question with 2 or 0. I can step 2, but the dumb solution I'm going to introduce to you is like that. Watch this. I can say I have the least number from 1 to 100. But if I is not in C list, I can do that. I can get an if statement. What is C list? C list is the odd number just now we had. If any numbers from 1 to 100, but it's not in my odd number, I put it in the even number. But I want to say that I just introduced you this syntax, but actually this method is quite dumb. Okay, it's quite slow. But I just want you to know that I can have this if statement. That means if I not in C, why is it dumb? Is because I not in C is a very slow operation. But sometimes you may have some other things. For example, if I is some function that will produce a true false value, you can still do that. Okay. Okay, now is confusing time. How do I generate prime numbers in one line of code? I try to generate all the prime numbers from 1 to less than 50 in one line of code. The general idea is to use a very complicated nested list comprehension. First, I generate all the non-prime numbers, and then I erase them. And how do I generate all the non-prime numbers? This is how I generate all the non-prime numbers. So each time I generate a list, right? This is all the non-prime. J is from J times 2 to 50. And I get all these numbers. And every time I step J, why? What is the first line? 4, 6, 8, 10. The first list is all the number is a multiple of 2 except 2. The second line, all the multiple of 3 except 3. The third line, all the numbers of false multiple except 4, and so on. And I do until 7. Why do I have to stop at 7? I want to generate all the numbers to 50. Why do I have to stop at 7? You think about it. Okay, now I generate, these are all the multiple of numbers in before 50. So very simple. I concatenate it into one list. So this is the same line for J in the range of I times 2, whatever is how I generate that. But I just mix them together into one list. This list is all the multiples. For example, this is a multiple of all 2s. This is multiple of all 3s. And so on. This is multiple of all 4s. So the whole list contains all the non-prime in 50. And what you just need to do is generate the numbers for X is in range of 1 to 50. If X is not in that non-prime list, then the list is, you can see my prime list is all the prime numbers in one line of code. Okay, so that is the interesting thing about Python. You can play this kind of tricks. And if you can master this list comprehension, you are already over the intermediate level, okay? So we'll encourage you to play around with this and see how you can make some interesting list comprehension notation. Yes. Sorry? This one is this one. This step. This one. What does it mean? For example, let's say J equal to 3. What do I have? I start with J times 2, right? J for, I equal to 3, right? I start with I times 2, which is 6. I want the list from 6 to 50. Starting from 6. But each time I step 3. 6, step 3 is 9. 9, step 3 is 12. And there's an all multiple of 3. So this list is generating the multiple of I except I. Because I can be the prime numbers, like 2, 3, 5, they are the prime numbers. That exclude them. I want to generate all the multiple of 5. Right? Okay. Good question. This is not easy to understand. Okay. Okay. Are your brains still okay? Yeah. Okay. We'll go for something easier. Okay. Tuple is easier actually. I let you go first. Okay. At least today's the torture is up to now. Okay. you have more of the torture in your tutorial. Okay, so but up to now first. A tuple is basically like a list, very much like a list. Okay, how do I define a tuple? A tuple is only different by a tuple cannot be modified. For example, I can have this tuple. Do you see what is the difference between the tuple and a list? I didn't say it's a tuple, but why is it a tuple? The list use the square blanket, right? What does the tuple use? Use the round parentheses, okay? And this is the difference. I can still do the access like that. Does it look like a list? Very much like, right? I can access a second one. But the only difference is the tuple you cannot modify. Remember the list you can modify, right? The list, I can say the central element, the index one, I can modify to 999. Just now I can modify. But list, the tuple cannot. Okay? Tuple cannot modify. And you cannot append. If you cannot modify, of course, you cannot append. So tuple is a more strict data type than the list. You cannot remove, of course. So all these things cannot be work on tuples. So the trap is there's some small thing. This is different from the tuple to a list. Now I have a list. The list I have 3, 5, 8, right? Okay, no problem. How about how do I define a list with one single item? Simple lah, like that, right? But how do I define a tuple with one single item? For example, I define a tuple of 3 items. Okay, no problem, right? But if I define a tuple with 1 item, can I do this? Why? Why is not a tuple? Why is B tuple is not a tuple actually? You ask your primary school nephew or whatever, what is have a parenthesis with 3? It's 3 what? Right? So if you want just put 2 parentheses with a 3 inside, it is not a tuple. Because it's just a normal math expression. When you ask your 6 years old nephews or cousin, whatever it is, okay, it interprets as that. So the problem is, what if I really want one single tuple? What will I really want that? The correct way to do that is, I'm sorry, you have to do this. You have to do 3 commas, okay? 3 parentheses with 3 commas is a tuple with one single item 3. So be careful of that. Okay, when you want to name one, this is usually what people got it wrong. Yeah, but so just have some, for example, you see, if you have a list 1 is equal to 1, 2, 3, right? List 1 is like that. So just now we show that a list you can modify, right? List you can append. List you can say the first element is equal to like that. So list 1 can be modified, right? But a tuple cannot. Let's say if a tuple is equal to 1, 2, 3. This is the tuple, right? And the tuple, can I say the first element is equal to 1, 1, 1? Cannot. Tuple cannot be modified. And tuple of cannot be append. Oh no, I don't. Sorry, wrong. I cannot modify the tuple, right? Tuple object does not support item assignment. So tuple cannot be modified. But the thing is, then why do we have tuple? Why do we have list? What circumstances will use tuple? What circumstances will list? Okay. English grammar time. This one I didn't discover until I was 40 years old. I have more than 1 fish, therefore I have many fish. The second sentence, I have more than 1 fish, therefore I have many fishes. Which one is grammatically correct or not correct? And why? Let me have my coffee first. Why? Are they all correct? Or what? I'm sorry to say that is my inability. Until 40 years old, before I read the storybook to my son, I all the way think that only the second sentence is correct. The first sentence is not correct. Until I read a storybook, wow, this guy that they caught many fish. I thought, hey, how come your book so lousy, have typo? And then at last I know that fish can be plural. Both of them are grammatically correct. Why? Okay, I don't know if it surprised you. Your English may be better than me. Okay, but why? Why there are fish and fishes all plural? And I go and check on it. The plural of fish is usually fish. Why? When we refer to a lot of fish in one type, we call it fish in plural. When we talk about in the ocean, there are many species, we talk about fishes. That's a usual convention. Of course, culturally or grammatically, unless you're very evil, usually people will not really go into that. But in general, if your tank is full of the same type of fish, you can say this tank is full of fish. If your tank is the ocean, definitely do not only have one type of fish. So you can say the ocean is full of fishes. Okay. Why do I mention that? The left one is a homogeneous type. I have many items, but they only have one type. The right side is heterogeneous type. Okay. Usually, for the difference of using list and tuple, we have something called cultural reason. That means by convention, we do that. If you don't do that, it's okay. You just look weird, okay? But it's okay. The cultural reason is usually the list, you use it to store a large collection of live fish. That means they're the same data type, or they mean the same thing. For example, if I store a collection of 200 students, all the single items in these 200 students are each of them are the same. They're all students. So usually I will use a list. But if I want to store a few things with different meaning or different types, I will use a tuple. For example, if I want to use a record, I want to say that I want to store it, a record as inside have some few items. One is a student name, one is a number, a marks. They are heterogeneous. Then I will use a tuple. Okay. So for example, here, if I want to store the coordinate of 100 restaurants in Singapore, I will do this. So what is this? The location of nice restaurant. That is a list of tuple. Why? Because each tuple, you say two numbers, they're the same. Why I use tuple? Because one means X coordinate, one means Y coordinate. But all of these free entry of 100 entry, they're all the same. That's how I use a list. Usually convention is like that, okay? But of course, if you want to implement a list of tuple or tuple of list or tuple of tuple, whatever, is okay. Okay, but usually there was convention. The other, so this program how to generate that only, okay? The other one is the technical reason. Anyone know what is this? Yeah, it's a save icon. You know there's physical object, right? You don't know what is it? This is a physical object. There was this story about this father. Once in office, he bring back this to his daughter. And his daughter said, Daddy is so cool. You 3D printed the save icon. No, in the beginning, it's a floppy disk. That's how we store data. We don't have USB drive. We don't have cloud drive. we carry this, and we store data inside our program. At our time, when we hand in a final year project, we hand in a disk like that. Okay? And this awesome disk, you know what is the volume of this disk? This is very good. It stores 1.44 megabytes of data. It cannot even store one photos now you take for your iPhone, okay? But at our time, this is how we do our program and project. So, for example, in our time, we didn't even have CD yet. So when we install Windows, you know how we do? When we buy a Windows system, we need a box of many disks. It's like 10 or 20 disks, you buy it. And then you install one disk, and then the Windows system will ask, you have finished this 2. Can you replace this 3? And so on. You keep doing that for half an hour, then you install your Windows system. It's not like now, everything online, okay? But one thing, of course, it's like your USB drive. Sometimes your disk is containing some variable data. How to protect this? The disk itself have this little window, can mechanically toggle it. It's like a button. What does it do? When the button open, there's like a window, you open a hole there. It's a hole you can see through. If it's open, that means your disk cannot be written by any disk drive. It's called write protection. Otherwise, if it's closed, that means you can freely remove, modify, write data on this disk. So this button is called write protection button. And it's the same thing for the list and tuple. The list cannot be modified, but the tuple cannot be modified, but the list can. Why is it important? Again, remember this pass by value? What's the output again? This is the primitive data type. The first line go into change value of print 999, right? What is the print of the last print X? 0, right? Because you have a scope, you have a new n whatsoever, okay? That we went through last lecture. So it's called pass by value. Remember why? Because pass by value means outside you have an X. When you pass the value into the function, you only duplicate the value, not X. So X is X, S in N. They are separate. That's what we talk about. However, for list, it's not the same. Okay, that's where the nightmare begins. I write a function called change second. That means I would use, if input is a list, I change the second item to change. What do I do? If I say I have a list of 1, 2, 3, I call the item on this list. Inside the function, I will change the second one to change, right? So what will be printed? It will say 1 change 3, right? Inside the function. But what happened outside the function? So inside, you print this one, right? No problem. It's inside the function. But when you come out, you print again, it's totally different from the pass by value. The list got changed also. Why? It's because the story of Alice and Bob. Okay? So for a list, when you pass into the function, it's a different story. Remember this diagram. So when this function, you have a list. This is, I think, here. When you pass this value to, when you pass the L into A, here, A inside the function only pointing to the original L. So this story is totally different from the past value of primitive data type. That means there's no duplication. A is L, L is A. They are the same list. So that means inside the function, when you change the second one, outside L also change because there's no duplication. This is very confusing and totally different story from the change by value, or pass by value, okay? So this is why if L is a tuple, then it cannot be changed at all, right? So that's why people use tuple. If I'm the one who called the function, I may want to convert my list into a tuple for it to pass into, rather than somebody inside the function may change my value. Okay. Okay, I don't think I'm going to set a dictionary because let me leave it to next time, or let me finish it first. Because the file IO, now I'll do this before the file IO. This is simple anyway. Okay, yeah, let's just go for it because it's time already. This is simple in explaining, don't worry. I put the more difficult one before because your mind may be tired by now. Set is very simple. You learn about set, right? Set is an order. What is the difference? You cannot generate the item. For example, if I set of all this, a set is a notation you can only keep one copy. So for example, this, I have this duplicate number, right? The set will help you to eliminate the duplication. And what is the, so we'll remove the duplication for that. And remove, this is important, huh? The tuple use the round parentheses. The list use the square blanket, and the set use this nice bracelet. And if the set is unordered, all this cannot be used, right? You cannot refer to which position in the set. And you cannot add, you cannot multiply. Why? Adding is a bit, you cannot just add, okay? But you cannot multiply. Multiply means you duplicate, right? But a set, you do not allow any duplication of the items. So you cannot. So remember all these set operations? You guys assign people, right? A minus B, whatever. So I don't spend here in explaining that, right? For example, A and B, the set of A is all Singaporean. The set of B is all male in the world. So what is A in the set B? Is the all male Singaporean, okay? So this is the set operation. I assume you guys are engineer. I assume you guys remember this. So you can do this for set. For example, I have a set of 1, 2, 3, 4. I have a set of 3, 4, 5, 6. So this is the union operation. It's just adding the set. But in the middle of adding it, you remove the duplication, okay? This is the intersection. So that means the only common item between the two sets will be kept. This is minus. So anything in A, not in B, they'll keep. This one is called mutually exclusion, okay? So that means is union of A and B, but I want to exclude what is their common. That is weird, but sometimes you have to use that. So you can remove something from a set or add something from a set. Remove one item from a set, Python have two functions for that. The only difference is if you do remove, if the item was not in the set, you got an error. But if you use discard, if the item was not in the set, let it go, okay? So it's just let go. It doesn't cause any problem. But which one is better? It depends on your usage. Of course, the first one may cause error and crash your program. But if you do that, maybe that means something wrong in your program. Using the second one is painless, but you know, for example, for human being, what is our pain system? Is it useful? Yeah, when you get old like me, it's very useless. It's very troubling. But for you, The paint system actually help you to avoid danger. You touch something hot, you slowly move, right? The paint system helps. So the error actually gives you what's going wrong in your program. You correct it. So actually people will prefer the first one, but it's up to your user. Okay, so you can add things from the set. And one of the very powerful usage is called dictionary. You guys, sorry, today a lot of ritual things. In the beginning, there was dictionary. Dictionary is when we were at home, we have this very thick book. We don't have internet when we were young. We had to flip through this big book to find the words meaning, okay? It's not like today, you just flip the phone and then you have the translation. But this is a structure we still use today. It's just electronic. You just simply a word and you give you the meaning, right? And then you have a word, you give you a meaning. That's what dictionary is about. This structure is going to with you if you continue on CS 2040, whatever you go on, you need this. It's actually a mapping function. I ask you this, you give me the record. It's actually like a database query. So it means in dictionary, I give you a word, you will tell me the meaning. Each word has a corresponding meaning in a dictionary. For the Python dictionary is, I have a key and a value. They are the similar things. The dictionary is being identified by the key. And if I give you the key, you give me the whatever the value. The value can be anything. Can be a list, can be a string, can be a record, can be whatever. But the key has to be immutable. For example, here, that's how I construct a dictionary. Dictionary, you use the same format as a set, and dictionary have this pair. There's a key value pair. You use the key to access the value. So how do I access it? Does it look familiar? The student, you have this square blanket. Originally, if it's an array or a list, you put in an integer, right? But now you put in a key. If you have a key, you will output your value. So remember that? So for example, how about I want to build a Hungry Go Where, okay? I want to input what is the position of the restaurant and you tell me what is that. For example, this position is Pizza Hut and so on. So what I can do is the key is the location, which is a tuple. The value is the restaurant name. So I can construct a location dictionary like that. You can see my key is a tuples. And if I ask what is the location of 2233, then I can output, oh, that's actually the Pizza Hut. Okay, so you can actually use this key dictionary. And of course, you can add more things into the dictionary, modify the dictionary, and so on. If you remember, what is a list? A list is actually every item is indexed by an integer. I would say it's like vending machine. Vending machine is you type in the numbers, then we'll give you. So you input a number to the vending machine and output you the item. That's what the list do. The list, you can only input a number. You went to Japan before? Japan is like that, right? Everything a vending machine. So you don't input a number. You tell me what it is. Instead of just a number, you tell me what is beef noodles more, okay? Instead of putting a number, you can directly say beef noodle. And they'll tell you what is the price or give you a noodle whatsoever. You can directly output whatever you want for the beef noodle. So it's just a more flexible list. Instead of inputting a number into your dictionary, you input any item. There's a key. And you can, so every dictionary entry have this key value pair, and you can change them. Key value, key value. You must do that. And they are separated by a colon. It gives you, okay, this one. Oh, this one is called hash table. You can use it to keep track of your record. For example, if you are today the fruit store guy, I can say, oh, how many apples do I have? 450. How many orange do I have? Then I can check my stock. I can check what is my stock of my apple? I can tell you it's 450. What is the stock of your apple plus orange? You can tell you the sum. And you can change the values or this get. Of course, if you try to get something not in your dictionary, you have an error, right? For example, I can add. How do I add a new entry in the dictionary? I can just simply get the dictionary, and I say, now I have a new pair. Here is equal to 100. So originally, I only have apple and orange. And now I add a new pair. I can add any dictionary entry just like that. And of course, I can override existing value. For example, now, my number of orange become 100 instead of 200. You can change that. I can say my fruit inventory of orange now become 100, right? And I can remove. Pop is removed. That means I will going to extract this apple, but erase it from the dictionary. Of course, you have other things, okay? But I will say there are other functions. I'm not going to tell you all, but I want you to focus on this. Go home and see what are these three functions. These three functions are extremely important. Make use of them, and it will be definitely tested in midterm and finals. And I purposely don't teach you that. Go and play around with it, see how to do that, and do some for loop for that. For loop. The dictionary can be for loop, okay? Play around with that. That will be your road to A or B+. And finally, yep, that's it. We finished the whole sequences and so on. It's not easy, okay? Today we have a lot of volume of information, and thanks for bearing with me. And before that, let's see any question in the poll everywhere. I think you guys are quite stunned, right? Yeah. Yeah. It's not really recursion, it's a pointer things. You can think of it a bit like recursion, but it's an infinite vicious cycle recursion. Will there be charging point provided during the midterm? I think so. I think we are using this theater also. There should be some charging point below your seat. Can you have a look at that? It's under you. Oh, no more questions. So if you have still more questions, please post it. And otherwise, please remember to do your homework. We'll ask you, what if I want to replace an element in a list without alternating the original list? You have to do copy, okay? Then we'll talk about that later. You have to make a copy of the list. And can we use it? I think you can, right? Is it? You can ask you this one, right? I don't know. Actually, I have no idea. Yeah, I think you can. This one, please confirm with your department, okay? Thank you, and we'll see you. Wow, it's a big. Okay.